Hello friends, welcome to the course Foundations of R Software. Now in this lecture we are going to begin with a new topic which is about factors. So as usual, what is a factor? That is my first question. Now if I try to give you a very simple example, you will understand it very easily. You have seen that many times we try to collect the data on the gender of the people, like as male, female, etc. Now, when we are trying to collect the data male and female, then we always try to give it a value. For example, we will write, if the person is male, I will write 1, and if the person is female, I will write 0. Why this is needed? Because you see, means anyway, when you are trying to collect the data, after that you want to do some mathematical operations on it. For example, if you want to know that out of 100 students, how many are male and how many are female. So you need to count them, and for counting them inside the software, you need to convert them into a numerical value. So how to convert those characters, because male is a character, female is a character, how you can convert those values into a numerical value, that is the job of this operation factor. And in statistics, this is called as categorical variable or binary variable. Binary means when there are only two classes, but if there are more than two classes, in general you can define it as a categorical variable. For example, if you are trying to take some data on that how people feels after drinking a coffee, that can be good or say bad or say okay. So now there are 3 categories. So now for these 3 categories you want to assign them 3 numerical values. So how to get it done? That is the job what we are going to do in the lecture today, and we will try to see how we can convert or how we can associate a number with the categorical variable, and that is the job which is called as factor in the R software. Means we are trying to do the factorization. So let us try to begin this lecture and try to learn how to do this factor in R software. Okay, so if you try to see, we have 2 types of variables. One is here quantitative variables, in which we try to get the data on say their numerical value, like as height, that is measured in meters, 1.65 meter, 1.76 meter, etc. And another type of variables are here qualitative variables. For example, the gender, that is male or female, performance can be excellent, good, average, bad, etc. So now we always want to convert this data into some numerical values. For example, if I am taking the variable here as a gender, there are 2 possible values, male and female. So I try to take it here the variable x equal to 0 if the person is male and x equal to 1 if a person is female. And similarly, if there is some performance and that performance is like excellent, average, good or bad, then we try to give it a value here. If the performance is excellent, we give the number 1, if it is average, then we give the number 2, if it is good, then we number 3, and if it is bad, then we try to give the number 4. So now these values which we are writing here as say excellent, average, good, bad, or say male or female, they are called as labels. And whatever the numerical code I am trying to assign them, like as here 1, 2, 3, 4, or as say here 0, 1 in the case of male or female, they are the numeric code which are assigned to these labels. And these categories are stored internally actually as 1, 2, 3, 4, and these labels have been chosen in such a way such that they provide some meaningful names for each of the code here, right, like this. So now the main important thing what you have to learn is that the factors in the R software, they represent the categorical variables and are used as grouping indicators, right. You will see in statistics that many times we are trying to do categorical variable, categorical analysis, etc. So in R the same thing is called as factor. So let me try to give you here one more sample and try to explain you first that what is this factor. Suppose we have balls of 3 colors, say here red, blue and green. Now we try to give them a number. For the color red, we give the number 1, for blue we give the number 2, and for green we give the number 3, like this. And suppose now we have 5 balls. They are like this. First ball is red, then the next 2 balls are green, then the fourth ball is blue, and the fifth ball is red. So now this outcome of 5 balls can be coded by the numbers also. How? This red can be indicated by 1, green can be indicated by 3, blue can be indicated by 2, and this red can be indicated by 1. So if somewhere it is written like, say here I have got the ball number 2 and 3, that means I have got the blue and green balls. This is what we mean, right. So each this character is mapped to a code, and the factors, they represent the categorical variable and are used as grouping indicators. And these categories are stored internally as numeric code, and these numeric codes have been given some labels, and this label provides some meaningful names for each of the code, like as 1 is red, blue is 2, and so on. The order of this label is very important, because for example, the first label is mapped to code 1, second label is mapped to code 2, and so on, right. So the values in these codes are always restricted to some finite number, say 1 to k, otherwise how will you give it a number? So these k values are going to indicate the k discrete categories, right. For example, in this case, the color red ball is mapped to code 1, blue color ball is mapped to code 2, and green color ball is mapped to code 3. So this is the name and its code. So when we are talking about factors, then we have a vector of character string or the integer, and whatever in statistics we call as categorical variable, that is called as factor in the R software. And in the R software, each possible value of a categorical variable is called as label. Now you have to be very careful with my audio, because now there are 2 words, label and here is label, right. So please try to be careful whether I am saying label or label. So label will be like this and label will be like this. Okay. So a vector of labels is called a factor, and a categorical variable is characterized by a number of labels which are called as factor labels, right. And here in this case, the number of factor labels are going to be finite. Okay. So now the question is how to define the factors in the R software. So to define it, we start with a vector of values, and then we try to define another vector, the second vector that gives the collection of possible values, and then there is a third vector that gives the labels to the possible values, right. And in order to do it, we have a command here, factor, F-A-C-T-O-R. So this is a function that encodes the vector of discrete values into a factor, right. So if you have some data vector or a vector of strings or say integers, if you try to write down here factor x, then it will be done. So the command is like here F-A-C-T-O-R, and inside the parenthesis you write here x. And then in case if you have a vector that does not contain all the values, but it contains only a subset of the possible values, then we try to include one more argument that gives the value of the possible labels of the factor, like this factor x, and then inside the parenthesis say x comma, and then you write down here labels. Now at this moment you simply try to understand what I am trying to say, and as soon as I take an example, means each of this thing will become very easy. That is my promise to you, right. So the usual command for the factors in the R software is here like this, that we write down here factor, and then here x is the vector of integer or strings, and then we have here labels. So these labels are going to determine the categories of the factor variable, and usually they are sorted out with all the individual distinct values in the x. This is an optional vector, this is here labels, right. Labels of the categories in the labels here, right. The names of labels are stored in the labels, and after that you have here exclude. So exclude is going to handle the missing values. So it defines which labels will be classified as NA if the output is a factor. Output is obtained using a factor variable. And if you want to have more information about this factor function, I will request you that you please try to look into the help menu, right. And then you can see here there are factor variable, and then you can see here its dot factor, etc., etc., right. But anyway, now let me try to give you here one example, and which will make the things very clear. You all know what is this. This is a dice, and this dice has 6 faces in which there are these types of dots here, 1 dot, then 3 dot, and so on. So, there are 6 possible values, 1, 2, 3, 4, 5, 6, right, when you roll a die. So, suppose our dice is rolled 7 times, and we observe the point 1, then 4, then 3, then 5, then 4, then 2, and then 4, and all these values are stored in a data vector y. Now, as you know that there are 6 possible values in this dice. So, I try to store all these 6 values here in a data vector C 1, 2, 3, 4, 5, 6, and I try to give it here a name, possible dot die face. So, I am just trying to give it a name which conveys the meaning also. So, these are the possible values of the points on the face of the die, right. Now, what we want here, that now we have got this outcome, and this outcome is coming out of these possible values, and I would like to write this 1 as 1, 2 as 2, 3 as 3, and so on, so that when I am getting here an output like 4, I should be able to see here as FOUR 4. So, how to get it done? Let us try to understand. So, first I try to define here the labels of this die face. So, for these values which are here 1, 2, 3, 4, 5, 6, I try to define here a corresponding data vector which has got these values which are string, like as 1, 2, 3, 4, 5, and 6, and I give it a name here, labels dot die face, right. And now I try to take this data, this here y, and I try to use here my command factor, and I calc the labels here are the possible die face, which is here vector C 1, 2, 3, 4, 5, and 6, and then the labels on this possible die face is obtained by this command labels, which is here this data vector labels dot die face, which is here like this. So, now if you try to operate it, what do you see? Whatever is the outcome, I am trying to store it in the variable name fac y, that means the factor of y. So, now if you try to see what is the outcome of this fac y, let us try to give you here the value like ONE1, FOUR4, THREE3, FIVE5, FOUR4, TWO2, and FOUR4. What are these things? Can you recall your here this outcome data vector which was here 1, 4, 3, 5, 4, 2, 4, and now you can see what this factor command has done. This has converted this number 1 into ONE1, number 4 into FOUR4, number 3 into this THREE, and similarly here 5, 4, 2, 4, this is here like in say characters 5, 4, 2, 4, and these are here the labels, and these labels here are indicated by here 1, 2, 3, 4, 5, 6. That means these are the labels which have been used, and the data in the y vector has been converted using these labels, right. So, that is how the things work, and if I try to show you this operation on the R console, possibly this will make the things very clear here. So, this is now your here y, and this is your here the data vector possible die face, and then I try to define here this labels, and then I try to define here this here operation, this factor, right, and I try to store it in the variable fac y. So, you can now if you try to see here what is your here fac y like this, and if you try to change your here data vector, suppose if I try to take here the data vector like as here say 3, 2, say 3, 2, and so on, then if you try to once again do this operation factor, then you can see here what is the output here, this fac y is 3, 2, 3, 2, and now it is 3, 2, 3, 2, but in words. So, this is how now you can see that these operations are working, and now we come to an end to this lecture. You can see that it was a very simple topic. You are simply trying to convert some characters into some numerical values, and those numerical values are the labels which are provided by you. Well, these things are very common in real life when we are trying to conduct some experiment and trying to collect the data, because whenever you are trying to analyze the data, you always need to associate some numerical values. Unless and until you associate the numerical values, you cannot do the computation, you cannot do the calculations. For example, the way you try to work that how many students are male, how many are female, what you try to do, whatever is the data, say male, female, you try to give them a value like 1, 0, and you simply try to sum them 1 plus 0 plus 1 plus 0, and that will give you the number of people in the category 1, and the remaining will be in the category 0, and now you have to see 1 correspond to the male and 0 correspond to the female. So, that will give you the total number of male and female students in the class or in the school. So, now we stop here, and it is your turn to take some example, try to practice it, and I will see you in the next lecture with some more new topic. Till then, goodbye.